Station Houston on 2 for Sam. We are about 1 minute away, and we can kick this off on time.
Okay, sounds great. Thank you.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready for the event.
European Space Agency, this is Mission Control Houston. Please call Station for a voice check.
Station, this is David Honus with ESA. How do you hear me?
Hey, David, this is Space Station. Welcome to the ISS. I have you loud and clear.
Okay, great. So I'd just like to tell you that you're now connected with ESRO Italy, ESRO Portugal, and ESRO Luxembourg. I would just like to give the word to you for a few opening remarks and to say hello to everyone.
Yes, fantastic. Very exciting to have you all join me on board today from Luxembourg, from Portugal, and from Italy. And I'm looking forward to all of your exciting questions, and maybe we will try some fun things out together today.
Okay, so we're going to begin with a question from Italy. Italy, please proceed with your first question.
Fai tutta la domanda intera.
Ciao Samantha, bentornata al museo. Just few words. It's a pleasure to introduce you the first question from Italy. And I wait for you here again in your post-flight tour. See you soon. Bye.
Hi, I'm Giovanni Cansi from Cavalieri High School of Parabiago. And my question is, how do we use microgravity to do research on the International Space Station? And how is it different to doing it on Earth? Thank you.
Yes, great question. I guess there's like two aspects. One is like there are some things that only happen in microgravity, like, for example, the adaptation of biological systems, of like the human body, of animal systems, of plants, cell cultures, tissues, all of that, and how those biological systems adapt to weightlessness, you can only study in space, right? But then there's also phenomena where the fact that you can switch off the effects of gravity up here, you can pretend that gravity does not exist. It takes away all the effects that are driven by gravity, and then you can observe other phenomena. For example, and we might see that quite soon, buoyancy up here does not play a role, which is interesting, for example, for the solidification of metals.
Okay, so now we will switch to Portugal for an experiment. Portugal, please go ahead and explain your experiment.
Hello, my name is Henrique and I am from Quinta da Medideira. This is my question. On Earth, we see that water and oil do not mix and the oil is always on the top. What happens in space?
Yeah, that is very interesting, and I have confessed I have never checked, and so I would suggest let's find out together. I have prepared this bag of water. There's just water in there and maybe some air bubbles. I hope you can more or less see it. And I have sacrificed a little bit of my supply of olive oil for the purpose of science today. So just hang on for a second as I grab that. So I have a syringe with olive oil in my hand, and we're going to squirt it into that bag of water and see what happens. Come a bit closer. Here we go. And now I would say let's mix a little bit. Let's shake it. And here's what happens to it. You've got a bunch of olive oil bubbles mixed in there with air bubbles and in the water. And indeed, they do not seem to separate, which makes sense because, as we said earlier, there is no buoyancy up here.
That's very good. Oh, wow. Thank you so much. Okay, so now we're going to switch to Luxembourg. Luxembourg, please proceed with your first question.
Buongiorno, Samantha. We are here at Luxembourg Science Center and super excited talking to you. I'm here with Furkan. He is 10 years old and he has the following question to you.
Does being in microgravity mean that tools used during a spacewalk, for example a hammer, work differently?
You know, for sure, to do a spacewalk, you have to wear a very bulky spacesuit, a pressure suit, that also has very bulky gloves. So you don't have much dexterity in your fingers, in your hand, and the gloves are just big. And so all the tools that are made to be used on a spacewalk are actually kind of like, they look like bulky and big. But the reason for that is that you need to be able to handle them with those, you know, with your gloved hands. And so they look a little bit different in that sense. And in terms of a hammer, I've never been really trained to use a hammer on a spacewalk, but I did see one that the Russians have that was developed for that purpose. And what is different about it is that they made sure to have like a moving mass inside the hammer so that it dampens the back slash that you're going to have if you try to hammer something. You don't want it to like slam back at you. And so they have this dampening moving mass inside the hammer to prevent that.
Okay, thank you, Samantha. So we'll now switch back to Italy for an experiment. Italy, please proceed to explain your experiment.
Good morning. everyone. My name is Riccardo Granito from Kennedy Middle School in Bulgaria. I'm here with my classmates and we'd like to ask you this question. Is it possible to yo-yo in space?
Yeah, that's an interesting question. I actually saw a video of a colleague of mine years ago doing some really cool yo-yo tricks. But he had like a yo-yo with a free spinning axle that could like stabilize itself gyroscopically. We'll talk about that here in a second. So I have a plain yo-yo here, and I can show you. I cannot do great tricks because I think a lot of those tricks rely on gravity, like, you know, walking the dog with no gravity pulling on the yo-yo. It's very hard to do, but we can give it a try. Let's see what happens. Let's see. See, it kind of comes back at you without you even having to pull. It kind of wants to come back at you without having to pull like you would have to do on Earth. But here I have something else to show you, which is also really neat. I have a little toy gyroscope. Now it's the gyroscope is not turning now, right? So I can turn it around, and it's just gonna, you know, let me move it in all directions like any other object. However, if we make it spin, see if I can make it spin. Now, it's not going to let me move it. I mean, I can push it, but it's going to keep the same orientation in space. See, the axis doesn't change. I can push it around, but it maintains its axis. And this is gyroscopical oh, sorry, need the mic. What I was saying is that now that I got it to turn, to move, the gyroscope, I think you saw it, I could push it and move it, you know, left and right, up and down, but it would maintain its axis. It would not let me like spin it and turn it around its axis. And that's gyroscopic stabilization. And we use that a lot in spaceflight, and even up here on space station, we have 4 gigantic gyroscopes that help keep space station in attitude.
Thank you, Samantha. Okay, so now we're going to switch back to Portugal for another question. Portugal, please proceed with your next question.
My name is Diogo Vaz, and I come from Escola Secundária de Gondomar. On the ISS, you live in microgravity. We would like to know how your stomach feels. Does it feel lighter like it does on a roller coaster?
Right now, my stomach feels empty because it's lunchtime, so I'm a little bit hungry. But other than that, yeah, I think it feels more or less like on Earth. So eating and digesting, I have the feeling that they work really well also in weightlessness, in microgravity. Your digestive system has a way of handling that and pushing things in in the right direction, even in weightlessness. Yeah, I mean, in terms of like feeling queasy and a little bit having a little bit of nausea, that happens to some astronauts or to some people in general when you get to space, and it feels a little bit, I think, like being seasick or sick in a plane or in a car. But again, our body, and then, if you're sick in those first days, obviously you don't want to eat, right? You might have a little bit of nausea. But, after a few days, everybody feels fine. The body adapts. And it's a testament to the adaptability of the human body that we can adapt to that.
Okay, thank you, Samantha. Okay, now we're going to switch back to Luxembourg for an experiment. Luxembourg, please proceed to explain your experiment.
Yes, buongiorno, Samantha. So our next question from Luxembourg will be asked by Carla Muttoni. She's a student from the International Space Program from the University of Luxembourg.
Hi, Samantha. Can you show us the effect of surface tension when squeezing a wet towel?
Yeah, absolutely. Let's try that. That's fun. Here, I have a little washcloth little towel. I already squirted some water in it, but we can add a little bit more. While I do that, I'm going to show you again the oil and the water after a while. See? They still didn't separate. Let's see. Right, I'm going to come a little bit closer. All right, here we go. That was pretty neat, I thought. I hope you liked it.
Okay, thank you, Samantha. Right, now we're going to switch back to Italy. Italy, please proceed with your next question.
Just a second. That's awkward.
Hi, good day. My name is Salma Saifullah. I'm from Indonesia. I'm from the Anderson International School of Milan. And my question for you today is it possible to make a cup of coffee in space?
That is a very important question. And so you can make coffee in space. Usually we have coffee in pouches like this, so they come with coffee powder in there, and you just add water, and it's like instant coffee. A few years ago, we even had an espresso machine on board, and we could make a real espresso. And then we even had zero-G coffee cups, so you could, take your coffee and squirt it into this very special cup, and you could drink it out of this cup. Now, usually what happens in space, if you want to put liquid in a cup and you do that, actually nothing happens. The liquid doesn't come out because there's no, we are weightless. But that cup had a very special angle that made the fluid want to come out per capillary action. And so you could actually enjoy the aroma, the smell of the coffee, and drink it out of this very special cup.
Okay, thank you, Samantha. I've just been informed that we have time for no more questions. So I would just like to thank you for all your answers and just pass the word back to you for some closing remarks and to say goodbye to all the sites.
Yeah, fantastic. By the way, I'm here with Paxi. So Paxi also wants to say hello. Fantastic talking to you guys in Italy, in Milano, I understand, in Portugal and in Luxembourg. Nice to hear that we even had a participant from Indonesia. So it was very much an international call today. Please keep up your great work, your interest in science and in space, and maybe I will greet some of you as a colleague in a not so distant future. Bye.
Thanks, Samantha. Bye-bye.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants from ESA. Station, we are now resuming operational audio communications.